The last two parallelograms that we're going to look at here in Chapter 6 are the rhombus and the square. And what happens with the rhombus, we're going to see a couple properties here to begin with. The diagonals are going to be perpendicular to each other. So we know with any parallelogram, diagonals always bisect each other. So we know that we have that to begin with. So if it's a parallelogram, the diagonals bisect each other. Okay, but specifically if it's a rhombus, they are perpendicular. Now the thing I would always remember about the rhombus was that all four sides were equal. And when I first studied a rhombus and I heard all four sides were equal, the quadrilateral that I pictured was a square. Didn't think anything differently, but the square is really what happens when we combine the rhombus and we combine the rectangle. If you remember, the rectangle not only had diagonals that bisected each other, but it had 90-degree angles in every corner. Everywhere we went on a rectangle, we had 90-degree angles, all four angles. So if we do that, if we have all four angles 90 degrees and all four sides equal, that's where we get a square. So the square really has all the properties of everything that we've studied. It's a combination of the rectangle and the rhombus all together, and of course it still also has all the properties of any parallelogram. So you have your rhombus, where two major properties are that the diagonals are perpendicular to each other, all four sides are equal, and also the diagonals bisect the angles. Okay, another property I think that oftentimes gets overlooked or we forget about, but we're going to get angle bisectors in there, which we don't have in a rectangle. You think about a rectangle, and I'll really try to exaggerate one here. Okay, in a rectangle, the diagonals are definitely congruent to each other, and they bisect each other. But notice I'm not bisecting those angles. You can see that this angle here and this one over here are not going to be equal to each other. But in a rhombus and in a square, when we combine that rectangle properties with the properties of a rhombus, we have our square. So that's what's happening here in our last section in the parallelograms that we're looking at. Okay, so in every one of these examples, we're going to be thinking about quadrilateral ABCD, which is a rhombus, just specifically a rhombus. So what we want to keep in mind as we look at this is that the diagonals are going to be perpendicular, so we have right angles along there, and then also that these angles are being bisected here. So we have equal angles here, and so on. Okay, so you may see that what we have is four congruent right triangles living inside here. And then don't forget, it still has the properties of any parallelogram, that the diagonals would bisect each other. But then finally, it also has all four outside sides equal to each other. So we have, by whatever property you want to think about, side, angle, side, you have four congruent triangles happening in each one of these pictures here. So in the first example, let's look at what's happening. We have the measure of angle A to B to D is 60 degrees. So if I know this angle in here is 60, and I want to find the measure of angle B to D to C. So we're talking about from B to D to C would be this angle in here. Okay. And remember, if I know that this is 60 degrees, this is bisected. We just said we have congruent triangles here. So if A to B to D is 60, then this would also have to be 60. The opposite angles in any parallelogram are equal, and we have angles being bisected. So measure of angle B to D to C would also be 60 degrees. They would have to be equal to each other. Okay, still hanging on to the same picture here of rhombus ABCD. We have AE, which is half of one diagonal. AC is 8, and they want us to find AC. So it's going to be really easy. Our diagonals bisect each other. So if A to E is 8, then there's another 8 that goes from E to C. So AC would have to equal 16. Right? And the next graph that we have in front of us here, they tell us that AB is 26, so I'm going to draw that in my picture. And they tell us that B to D, which is a diagonal, is 20. So we're going to run this way. That whole diagonal is 20. But what I'm going to do is give myself a little bit extra info here and say that those two pieces are going to be 10 each. And then, of course, they want us to find A to E. So we're trying to find this length here. So the reason I separated that 20 and divided it into two pieces of 10 each is because we can see that we have a right triangle here. I have a right triangle. I'm going to draw it off to the side here, where I have B living up here. Here's my right angle that's in the middle. This is where E is. This was 10. And then this side from B to A, they told us was 26. So if I want to find this side AE, we're going to use the Pythagorean theorem. Okay? If I wanted to call AE x, then I know that x squared plus 10 squared equals 26 squared. So we subtract 10 squared from both sides. So I know that x squared, which is what I'm looking for, is 26 squared minus 10 squared. So 26 squared is 676 minus 100. So we know that x squared is 576. So if we take the square root of 576, x is going to equal the square root of 576, which is 24. And that's what we were looking for here. We wanted to know what AE is, so AE in that situation would have to be 24. And then finally, we want to find the measure of angle C to E to B, and we don't have any other information to go along with that, but from C to E to B, we're talking about this angle here, and we know that that angle, since this is a rhombus, we know that that has to be a right angle, so that would have to be 90 degrees. Oops. Now they tell us that the angle from C to B to D, so if we go from C to B to D, we're talking about this angle in here, they tell us that that angle is 58 degrees. And we know we also have a right angle living in the middle here. This is a right angle, it's 90 degrees. They want the measure of angle A to C to B. If I go from A to C to B, we're talking about this angle right here. So we know there's 180 degrees in this triangle. Let's focus in on this triangle right here. There's 180 degrees in it, and I have two angles already living in there. One of them is 58, the other is 90. We subtract those two from 180, and we would get 32 degrees. Okay, so that's this angle in here. A to C to B would be 32 degrees in there. Okay. And now in the next one, that information does not, from number 5, does not carry over to number 6. We'll check and see what we have here. They tell us that A to E is 3x minus 1. Okay, and then they tell us that A to C, this whole segment here, is 16. Okay, well, if the whole segment's 16, and we know that the diagonals bisect each other, we know that each one must be 8. So my equation to find x would have to be that 3x minus 1, that piece that goes from A to E, is half of the whole diagonal, will be equal to 8. Okay, so we have to be clever. Notice I took the 16. If you're wondering where the 16 went, it's still there. But since the diagonals bisect each other, I divide it into the 2 so that I can solve this equation for x. So I have 3x minus 1. Oops, we got rid of the minus 1. And now we just have 3x equals 9. Really easy one-step solve now. So we divide both sides by 3. And we find that x equals 3 in that situation. Now notice the next one is focusing in on angles. So hopefully the fact that we have a 90-degree angle living in the middle here will be of some assistance to us, because that's a property unique to our rhombus. So here they tell me that angle C to B to D is 6y. So that's right in here, 6y. That's this angle, C to B to D, is 6y. And then A to C to B, which would be this angle in here, kind of hard for me to fit it in there, is 2y plus 10. So we have to find y. Well, what do we know about all three of these angles? 90, 6y, and 2y plus 10. They always add up to 180 degrees. So we have 6y plus 2y plus 10 plus 90 will add up to 180 degrees. So we'll combine like terms. I have 8y plus 100 equals 180. And now I'm going to subtract 100 from both sides. So I have 8y equals 80, and pretty easy solve now. Divide both sides by 8, y equals 10. And I always feel like it's easier for us when we're given sides, because we don't have a lot of options with sides. Pretty much the only option is ever going to be that they're equal to each other. When we had parallelograms, opposite sides were equal. But there's not much fancy things we can do with the sides unless If we have diagonals, they could be bisected. We might have to double something. But here I have AD is 2x plus 4, and CD is 4x minus 4. There's not really any options I could have here. I can't say that one is half of the other. They're both sides in a rhombus, and we know that a rhombus has 4 equal sides, like the square. Okay, a square is just a more advanced or a more specific version of a rhombus because it has all 90-degree angles in its corners. So we have this pretty simple two-step equation. Subtract 2x from both sides. So 4 is equal to 2x minus 4. And then I would go ahead and add 4 to both sides. So we have 8 equals 2x, and then divide both sides by 2. So we just have x equals 4.